Hello and welcome. Today we are going to solve a problem from electrostatics. The problem says two charges plus 10 microcoulomb and minus 10 microcoulomb are placed at points A and B separated by a distance 10 centimeters. Find the electric field at a point P on the perpendicular bisector of AB at a distance of 12 centimeters from its middle point. So first thing we need to do is we need to draw a diagram of this problem, and then we will apply Coulomb's law, and that's how we will arrive at the result. So here are two charges. Here is the plus 10 microcoulomb one. I will consider this as A, and suppose here is a B charge. They are separated by a distance 10 centimeters, and P is on a perpendicular bisector. Let us consider this point as P, and this distance is 12 centimeters. Now since we'll need to find the electric field here, we'll just connect these two lines so that we can find the distance of this point between these two charges, and this becomes, we can clearly see applying Pythagoras theorem, that this AP is equal to BP equals root 5 square plus 12 square, that becomes 25 plus 144, and that is equal to root 169, that is 13 centimeters. So the field at P due to charge at A is given by U1 equals 1 by 4 pi epsilon 0 10 into 10 to the power minus 6 by 13 into 10 to the power minus 2 whole square, and that due to charge B is, well, let us call this EA, and that will help us. So field due to charge B is 1 by 4 pi epsilon 0. Since this charge is negative, this will be an attractive force and will be directed along this line. Well, we'll write a minus sign. Now one thing about electric field is that it's a vector quantity, so has a direction, and here since this force is repulsive, both for determining electric field, we consider test charge, and test charge is positive here. So this will be a repulsive force and will be directed in this direction, but this is a negative charge, so this will be attractive force and will be directed along this direction. So we can write this direction as AP. Now this hat means unit vector along this direction, like it just points the direction, this one, but has unit as its value, so it just does not change its magnitude. And also now we need to give a vector sign over here. So here the same thing will happen, except for the direction will be along PB. Now we need to find the total field at a point P. Now by the superposition principle, at some point the fields due to each other, due to two charges, can be summed. So at the point at P, so we can call that as EP, electric field at P will be the sum of the electric fields due to this charge and this charge. So EA plus EB. So 1 by 4 pi epsilon 0 10 into 10 to the power minus 6 by 13 into 10 to the power minus 2 whole square. Epsilon 0 Now you see this force is directed along this direction, this is along this direction, so the net resultant will be located directing in this direction. We'll just draw a diagram so that it becomes clear. So this will be the direction that the forces are both directed, I mean the net electric field is directed, and you can see the angle here that this field the EA will make with the innate, and also the angle that EB will make with innate are equal, both are theta, because the magnitudes of these forces are equal, and also they will be equal to this angle, as is evident from the picture. So we can find this angle as cosine of this angle as because this is 5 centimeters and this is 13 centimeters, so cos theta is this, and the projection of EA along innate will be EA cos theta, and that of EB along innate will be EB cos theta, so it will become where E is equal to EA and EB, since we're just considering the magnitude. Into cos theta, I've shown here that it is 5 by 13. So we'll use a calculator to find its value, and the value of this is 9 into 10 to the power 9. So if I'm using SI, which I indeed am, because here charge is expressed in Coulomb and here it is meter. Well, the displays. So this becomes, you can see this large value, we will copy it here. So 4.09 into 10 to the power 6 Newton per Coulomb, this is with the value of the electric field, and it will be directed along this direction, which will be at an angle theta equal to cos inverse 5 by 13 with EA, and this will be as the same angle with EB but in the opposite direction. So I hope how this problem is being done here, and to have a more clear concept, solve a few more problems by yourself. So up next we're going to see a different topic. Thank you.